Hello, everyone. We're going to get started at UpSCaLE in just a few minutes, but if you have not already gotten a drink ticket, go see my friend Brian in the back for your free drink ticket, and the bar will open shortly. And talks will begin even more shortly. All right, everyone, let's go ahead and get started. Welcome to UpSCaLE, the something annual UpSCaLE. I love it. You're already doing the first thing we need to practice, which is clapping, so you're on a good roll. I'm Hannah. I am the publicity chair here at SCaLE and also your host of UpSCaLE. If you've never been to an UpSCaLE before, you're in for a treat, not just because we have a bar, but because we have a lot of great talks as well. So we have 9 speakers for you tonight, and they all have, clapping. We're working on the clapping. You're all doing great already. We have 9 speakers, and they each have 5 minutes, but that's not fun enough, so we add a little bit of a twist in the Ignite style, where their slides auto-advance every 15 seconds. Yeah, we can cheer for that. It's a fun time. So they have no control over the cadence of their slides, which makes it more fun and a little bit less stressful. We don't want them to be perfect. We want it to be interesting. So we've got a wide range of topics, and if someone's slides are a little bit off, or they might have 5 extra seconds where they're waiting for their slide to tick, what can you do as an audience? We already talked about it. Not booing. Yeah, we can clap. Yeah, make them feel like they're doing a good job and they're having a good time, because we're all here to have a good time. We have a lot of first-time speakers as well, and UpSCaLE is one of my favorite places to have first-time speakers, because it's 5 minutes. It's a good place to dip your toes in. So I have told them all you're a very friendly audience, so prove me right on that one. A few other logistics is that the bar will open in a bit, and you're welcome to get drinks, but please do not congregate in the back and chat, because we want to be nice and quiet for the speakers. Otherwise, we're going to do that to you and call you out. All right? All right, are you ready for some talks? There we go. Awesome. All right, so without further ado, I'm going to welcome Scott to the stage, and he's going to tell us about Quick Basic Shell. So, welcome up.
Hello, I am Scott Williams, and I am a DevOps engineer and Fedora ambassador, and I normally talk about Kubernetes or Linux stuff. Today I'm going to talk about a passion project for me. Come to my talk tomorrow if you want to hear about Kubernetes, but this is Quick Basic Shell. It's a modern shell for modern operating systems, and it was written in Quick Basic and is pronounced QB shell, not QBash. Okay, our modern shell's too complicated, and so this is a self-owned. The one I wrote on the left this is Bash that I wrote a month ago in my day job. So that is some legit Bash. Is this too complicated for you? Do you yearn to go back to a simpler time, but your bosses constrain you to modern hardware? You know, they don't let you use 8 bits. You have to use 64 bits. I own both of these machines, by the way. That was my first family computer, the Osborne one over there. Then QB shell is for you. Yeah, so this is what it looks like. Print hello world is back. Those of you from the Commodore 64 era, rejoice! We're back, baby! So how did it start? I get to use a lot of complicated tools to solve some complicated problems, and one day I just went on Twitter, I said, what if we just went back to simpler times and we just had a basic shell for Linux? And it was just, all it did was basic things, and Twitter said, this is a terrible idea. It was unsympathetic. And so of course I had to do it, but the QB64 people also reached out to me and helped me get through some early bottlenecks. And that was really awesome because this is the first time I actually had connections with them. So that was so much fun. I thought, I actually kind of want to do this. My first thing was I wrote just a wrapper. All it did was took what you put into it and then routed it to Bash just so I could say I did something. And I learned really quickly it wasn't going to be that easy. But it was so fun I wanted to continue. So we have some really basic keywords. Just an example, clear clears the screen, print gives you a line, and then rand, if you remember the random number generator from BASIC. But then I drew inspiration from CPM, from Commodore, from Atari, and PDP. So if Nolan Bushnell or John Mad Dog Hall are still here and listening, thank you. You have been an inspiration for this. So some of our aliases were expanded, so like CHD or works from PDP. And if you remember pip, if any of you are PHP or CPM people, you can now run pip on Linux again. Just don't forget that destination equals source, not the other way around, or you will be sad. We also have 8-ball. We're an LLM. Before LLMs were a thing, it can predict and make decisions for you with near similar accuracy. Then we focused on documentation and help. So we have a help command that prints out friendly help, and we have documentation in our GitHub. Then testing, refactoring, and very helpful messages. You ever try to divide by 0? This is a helpful message. And so these error messages ensure sanity when you're doing file system operations and stuff. We try not to let you shoot yourself in the foot. And then we actually made this into a container with automation, and we support Arch. So you can run this on your Raspberry Pi or your System 76 Ampere thing out there. It should run on it natively with automated builds with Quay.io. And we even have a scripting engine. So you remember comments? Single quote in BASIC, those work now. White space is okay, and Crunchbang works too. And we improved the I.O. Okay, having Vim work in this should not have been as hard as it was. Let me just preface that. But Vim even works, and your interactive command, so if you just do DNF without the Y, you actually get the input and you can interact with it. And I can do some things that Bash can't do, like simple math and floating point built in, and emulating 2-bit PC speaker sound natively from your terminal, and it works with Pipewire. Who says Linux audio is terrible? We could do this. And last year we saw our first physical release, and here I have on you a floppy that has the source code and the binary. It just barely fits on a 1.44 megabyte floppy, FAT12 formatted. This has QB Shell version 1.2 on it right now. is open source. It's MIT licensed, and if you want to help, we could use your help with testing issues, pull requests, and I want to hear all about the adventures that you're going to have with QBShell. Thank you very much. And one last thing, it is QBShell, not QBash, and you can go to qbsh.org or find me on Mastodon. Thank you.
All right, we having fun yet? Awesome. For those of you who just walked into the room, welcome to UpSCaLE. We're on talk 1 of 9. If you haven't gotten a drink ticket, my friend Brian in the back has one. And if you're getting a drink when the bar opens, please do it quietly. All right, now that those fun things are out of the way, let's welcome up our next speaker, Catherine.
Hello. Oh, it works. Good. Okay. This is terrifying. I can't believe I have to follow that. That was awesome, by the way. Okay, I'm Catherine Druckman. I am an open source evangelist at Intel. I'm going to talk to you about a new-ish project under Linux Foundation Data and AI, or is it AI and Data, called Open Platform for Enterprise AI, because we're all really excited about AI, right? Innovation in the field of AI is moving incredibly rapidly. Everyone wants to sprinkle a little AI on an application or build a new one. There's so much excitement, right? But it comes with some challenges, maybe some hurdles, and I want to go over some of those, right? So when we're all excited about these new technologies, sometimes we don't have the benefit of best practices that have gone before us, right? We want things like interoperability because things are better that way. And vendor neutrality. So how did we get here, right? AI is not new. We've been doing this for a little while, but everybody's kind of doing their own thing, kind of innovating in silos. But what we really want in the project is interoperability, and we want the community to come together and establish those best practices together. Because, if we don't, we may not know how to pick our models, right? How to pick frameworks. There's so much out there. Something new comes out every day, right? And we might end up with this big, messy pile of Legos, or we might build ourselves a monster, right? Minimum viable product. We've all been there. Maybe it works pretty well. It's fun to build, but it could maybe be a little unpredictable, hard to expand, maybe has a mind of its own. So the solution, we think, in OPEA is a project working toward an interoperable, vendor-neutral platform that tames a little bit of that chaos. The mission is to create a platform that enables open and composable solutions. So again, introducing the Open Platform for Enterprise AI. OPEA will focus on RAG, I'll get to that in a minute, models, focusing on open models, of course, because we're open source people here, other things too. So what's RAG, right? I'll give you a simple example. If you ask an LLM about your mom, it doesn't know, because unless you're famous, maybe it totally does, but it's not going to give you a correct answer because it's not trained on that stuff. But, yeah. I normally have cat ears for this, but so a pre-trained model only has general knowledge, right? But if you give it context with the prompt, then it might give you the information it wants. So how do we give the model context? So here's how. If we provide some additional context with the prompt and then ask the same question again, we might probably get something better in response to a novel topic that has not been trained on. So again, I'm going to reiterate. Retrieval, I don't even have to read this one, y'all can read that. Retrieval augmented generation. Extracting relevant information from a knowledge base, enhancing the prompt with the retrieved context to provide a more accurate answer, and the model generates an answer. So think of RAG, retrieval augmented generation, as a two-step process. First, you need to pre-process and store your knowledge in a knowledge base. For example, if you ask, who is my mom, the system will search for relevant context to answer. There are, of course, multiple challenges, right, to building these RAG applications. What about the data? Which LLM? What about, and then deployment, right? That's a whole other can of worms. How do you choose which model? Guardrails. How about guardrails? Okay, anyway. So had we built on a more stable platform, we might not have created that crazy monster with a mind of its own. All of those Legos that we mentioned before, by the way, represent microservices, because we love our microservices. We can see that each microservice is designed to work together to serve various functions across this example chat Q&A application that I've been talking about. In this case, we have a user interface. The data is supplying it. Microservices point to each other and APIs. Shit. I knew I was going to do it. Okay, to do this, an embedding model converts the text of your question into numerical vectors, representing the meaning of the text, and then they compare. And then we wrap it all up in a megaservice so that the megaservice handles the communication between the other microservices and then communicates with a UI. Magic. I love that animated slide. So, how do you get involved? You want a little OPA in your life, right? Join us, join me in the security working group because we have our own set of challenges to work out. Talk to me after class if you want to hang out, because of course you do. And then scan that QR code. Thank you so much. This was really fun.
Right. Thanks again to Catherine. 15 seconds is really fast. She did a great job. All right. Let's welcome up Mark, who's going to be talking about misconceptions in open source contributions. We don't know about any of those, right? Let's find out. Let's welcome him up.
Thanks. So, can you hear me okay? Yes, good. All right. So, I became an open source contributor. I realized I made a bunch of mistakes as I was becoming an open source contributor. My proposal is you learn from my mistakes and make your own mistakes. Thank you very much, not my mistakes. So the first idea is make your own mistakes. I made mistakes around scope, scale, and skill when it comes to open source software. Those three things were the general places where I made the biggest, most glaring mistakes. Scope, scale, and skill matter deeply. 2007, I'm using Jenkins. I'm a manager at a little company. Yes, guess what? I know you'd have guessed that, huh? I'm using Jenkins. I'm a manager at a company. It's working. Hey, works reasonably well. Great. Misperception. I have nothing to offer. Oh, I was so wrong. Absolutely. Oh, it works. I don't need to help it. It doesn't. There's nothing I could add to it. It's just great as it is. It's 2007, people. That's a different time. There was a lot to do. I was wrong, all right? There was plenty that I could do to help Jenkins. Oh, that's a fun sound. That plenty that was there corrects my misperception. Open source projects need your help. Report bugs. Good bug reports matter deeply. Review other people's bugs. It's even more valuable if you'll please tell us. Write documentation. Help other people by describing. Review other people's code. If you're a non-English speaker, pretty please translate into native language. It helps a bunch. Those were things I could have done. Now, my mistakes on scope were a big deal. I also misperceived on scale. Scale misperceptions caused me to think that, oh, everybody's contributing to open source software. I won't be a help. I'm tiny. The data says differently. Over 1 million users, thank you, over 1 million users of Jenkins, and possibly as many as 10 million. But in a month, we get 600 contributors who contribute pull requests. 1 in 2,000 to 1 in 5,000. Even worse, 60% of the contributions in the last 5 years have come from 40 people. All right, you can contribute in a big way if you know that you are a part of a small group. Curl, Daniel Stenberg, 20 billion to 50 billion installs, 10 or fewer developers. Maven, millions of Java developers, 10 developers, 20 developers. Oh, but what about the time commitment? That was my other problem. Isn't it a permanent commitment? If I do a contribution, I must do it forever, always. No, that's not how open source works. Scope and scale, 2 mistakes. Skill was the other place where I made a mistake. I thought I didn't have what it took to be an open source contributor. I didn't know this. I was a manager. Come on, managers don't do stuff. I was wrong, right? I was wrong because what it needed was willingness to make mistakes, willingness to learn, willingness to take responsibility for my mistakes and fix them. Oh, I also thought everything interesting was already done, except in 2007, my fascination with source control systems, I thought RCS was really cool and CVS was wildly cool. And this little thing called Git came in, and it turned out the Jenkins project didn't have nearly enough tests in their Git stuff. So I started writing tests. Guess what? That was useful and valuable to them because they didn't have them. I wrote them. Okay, great. I learned JUnit. I learned something about HTML. I learned something about Selenium. Oh my land. Yes, I know it's a lot to learn about a bunch of testing technologies, and it was a great experience. I promise you, there is more learning ahead for me and for you in all sorts of places. If you're interested in it, there's likely a spot in open source contribution where you can use your interests to get more and better skills for yourself. Yes, my mistakes in scope, scale, and skill were real. Don't you make those mistakes. Try it, work with it, experiment, enjoy the journey as you go forward. Thanks, everybody.
Mark was so good with the time limit that we just asked the cell phone companies to issue an emergency alert just to see what he would do. And I think he did pretty good, so let's give him an extra round of applause. Just got to throw some extra wild cards. You don't know what you're going to get at UpSCaLE. So on that note, let's welcome our next speaker, Greg, who's going to talk about building an unbreakable IR plan. So let's give it up for him.
All right. So first of all, my name is Greg Kutzbach, and companies call me when they're burning down. So let's work on that. Incident response plans are confusing, but you need one, so let's make them less confusing. Duplos are your IR plan sections. Legos are your specific actions. Okay, why do they fail? They're either so generic they don't help you get through an incident, or they're so specific that they can't adapt to the real world. So we're going to work on that. I like Legos. Okay, so IR plans require structure, so build on the Duplos. Those structures are going to enable your clear incident management while it's happening. Otherwise, it's chaos, and it's chaos anyway. IR playbooks are your pre-chosen Legos for the scenarios you've prepared for. All right, so it's important to build your IR plan as phases, or Duplos. So when an incident's happening, you can use any simplicity that you can get. I promise you everyone will have an opinion, and you need to say, no opinions, we're following the plan. Okay. Although also no one has IR plans, it's really scary. So preparation, that's what we're doing right now. Detection, containment, eradication, recovery, and I use communication here because I think communication is the thing that keeps you from actually recovering. So let's keep on going through. Please make one of these. The Lego pieces are a step. Like changing all users' extra Entra passwords. Yeah, that's just one little Lego. That's one step in your plan. So let's say you have a phishing attack. During the containment phase, block the sender, reset credentials, notify users, check logs. Not too complicated. You built the Legos, you have the steps. Do the things. All right, let's go through another one. Ransomware. May have happened to a couple of you. Probably has. During the eradication phase, isolate the affected machines, restore from backups, patch your vulnerabilities. Again, seems common sense. It doesn't actually happen this way. Where's the documentation? Where's the logs? Who has the login? Oh, it's on the encrypted file server. Okay, during the detection phase of a Slack account compromise, remember Disney last year? That was 1 point something billion. Check the logs, reset the passwords, restore and revoke unauthorized sessions. Disney has budget, by the way. They aren't good at this. Okay, why playbooks are Legos, not Duplos? It's because they are basically just made up of your Legos. There's thousands of incidents possible, so you have to build enough Legos to build your playbooks. But you need to build it all on a strong foundation. So strategic Legos on top of your Duplos. Not every single Lego, just the strategic ones. So if you build your IR plan on sand, not the Duplos, it all falls apart. That's usually what I'm used to. So playbooks. They take time to build, so you need to make them malleable enough to work for multiple scenarios. If they're too specific, they don't work. So don't get too specific, and use your time wisely. You guys are all very valuable. Don't waste your time, and yeah. So make sure your building stays strong under a little bit of ground movement. So if your environment changes a little bit, maybe this plan was written 6 months ago, you moved over to something else, make sure it can adapt a little bit with you. Okay, so the role of people in IR plans, it needs to prepare people from all the core business units. That's not just IT, that's HR, that's communications, that's PR, that's your development teams. They're all involved in this. And they all need to be part of it. And that comes back to communication. So unclear messaging and communications kills a clean incident response. So ensure that your comms are planned, ensure your public PR comms are pre-written, pre-approved. Did you know that committees take a long time? Yeah, they do. So practice that. Tabletop exercises. Get everyone together, have a lunch, get some drinks on the table. Maybe not on your business, I don't know. But find the gaps in the playbooks. That's when you're gonna find out that your playbook isn't as good as you thought it was. And then always be thinking of your IR plan as a living document. So they change with the business, new threats, new lessons. Okay, so how do you scale it? As your threats and your impacts increase, as your $1 million business turns into a $10 million, $100 million business, you need to evolve your IR plan. So the Duplos stay where they're at, keep on building those Legos, and then you'll have new playbooks to put them into. They're multi-use. And the IR plan is never done, so you need to regularly review it. You need to review your threats of your environment. So don't think of the IR plan, think about your environment. Think about what you're actually protecting. How much damage is gonna happen or not gonna happen. So use that to design your IR. But in finale, build on your Duplos, test, improve, iterate, and you'll be ready for any scenario. Thank you very much.
Thank you again so much, Greg. Are your hands getting tired? Good. Because we're almost halfway done, so you got a lot of clapping to go. So with that note, let's welcome up our next speaker, Lahari, and she's gonna be talking about bias in AI. So let's welcome her up.
Good evening, everyone. My name is Lahari Chowdhury, and I'm here to talk about the topic bias in AI. So what does bias in AI actually mean? When you prompt an AI system with a question and the system generates a response that shows any type of unfair preferences or discrimination, that's when a system is biased. So how do these biases make their way into these systems? It's not just one, it's multiple factors contributing to these biases. So primarily there are three main culprits. It could be the training data itself, or it could be the design of the algorithm, or it could be us, people who are developing these AI systems. The assumptions and the backgrounds of these people could easily make their way into these AI systems. So at the end, it's not just the data problem or the technical problem, it's the combination of all these factors working together. Most of us use GenAI tools for various purposes. So how can we actually rely on these systems knowing that they are biased? Knowing that they could actually discriminate us based on various factors. So we should be concerned about this. We are all aware of the GenAI tools such as ChatGPT and DeepSeek. DeepSeek, which was recently launched, is well known for its capabilities. However, like all the other AI models, it is biased in its own way. Gender bias has been a significant issue in AI. When discussing about professions, these systems continuously default to traditional gender stereotypes, such as using he when an engineer or CEO is mentioned, or using she when a nurse is mentioned, showing how deeply these systems are embedded with biases. Also coming to technical biases, ChatGPT continuously uses Python for any type of programming task. DeepSeek simply overcomplicates any type of programming solution. This shows how these systems can actually pick up these preferences based on their training that they have received. It's not just these cases, you know. We have seen biases in multiple machine learning systems. For example, a research led by Joy Baumblini revealed that most of the commercial AI systems show higher error rates for darker-skinned women compared to lighter-skinned men. And also this is leading to potential misidentifications in security and surveillance systems. AI in healthcare has also underdiagnosed health conditions for non-white populations. This is mostly because of the training data as it lacked diversity, resulting in unequal health outcomes. There are also AI-driven recruitment tools, which have, in some cases, favored male candidates over female candidates. This is, again, because of the training data, because most of the training data was composed of male-dominant industries. It is important to reduce these biases in these systems because we have to make sure that the systems we are using are fair and are not discriminating. And also, these are adhering to ethical AI frameworks that prohibit these biased practices. We can use certain strategies to reduce these biases by ensuring that the training data sets are actually representing all user demographics and encouraging diversity among the AI developers to bring varied perspectives, and also establishing mechanisms that could continuously monitor these systems for any biased outcomes. We also need tools that could actually measure and detect any biases in these models. And at the same time, we have to allow users to report any biased outcomes for continuous improvement. There are multiple government initiatives emerging to regulate this evolving field. For example, the EU's AI Act has emphasized on unbiased AI systems to protect its citizens from discriminatory practices. These AI systems are continuously learning and evolving. And also their performance is mostly dependent on the quality and the diversity of data. So we have to make sure that the regular updates are happening so that they're not perpetuating any outdated biased outcomes. And the community involvement is needed now more than ever before. The community's expertise in various fields could actually lead to much more approaches in identifying and mitigating these biases. We need to come together to bring more open source and unbiased data sets to build these AI models. So addressing these challenges in mitigating biases is not only a technical challenge, but a moral imperative. By implementing strategies, we could harness the potential of AI in a manner that is fair, transparent, and beneficial to the entire society. Thank you.
Welcome to your halfway point at UpSCaLE. You're doing a great job. Thanks everyone who's waiting in line at the bar for not talking during the talks, for being really silent and watching the speakers, because they worked really hard on theirs. And I'm gonna ask our next speaker to come up, George. Yes, you can clap. Fun fact about George is that his birthday's next week, and that's really exciting. Yeah. So, George, I hear that you wanted to give the audience a gift for your birthday.
Drinks on me.
Sponsored by Intel. All right. So, again, thank you so much for being quiet in line. The bar will be open well past the talks, so don't worry, you will get your drinks. And let's give George an extra special round of applause up here for his last talk at his current age, which I will not disclose because it might be NDA or, you know, whatever that is. So, welcome, George.
I've never done this before. Let's go. Hi, everybody. I'm George. Today, I'm going to talk about contributing to the projects you love. I'm George Castro. I work at the Cloud Native Computing Foundation. Check out the shirt. And we got templates and all this stuff. Open source is a science, and I'm here to share the stuff that I tell over our 200 CNCF projects. Steve Langesek, we lost him this year, and we built Ubuntu together. And to me, it's important to get contributions in open source going and making that sustainable. And we are measuring everything at the Linux Foundation. I'm going to explain why here. First, understand the project. I am a project maintainer. Raise your hand as well. So we're going to go through a little group therapy here for users and maintainers. Understand the project when you show. Read the README. Watch the videos. Figure out what's about. What does it connect to? What connects to it? Who are we designing for? Well-designed projects have use cases. They say, this thing is designed for you to do this. Probably not this. Try something else. Think about that before you decide to do the contribution. Raise your hand if you contributed to documentation in an open source project. My first contribution, rejected. You know why? Because I didn't read the stuff beforehand. They changed the entire framework, and they had to throw away my work. Everyone felt horrible. Chop wood, carry water. I built my entire career moving stuff from left to right. There's only one Linus Torvalds. The rest of us just get to work and get it done. Find the low-hanging fruit first. Don't be like, hey, I'm going to re-architect all the Kubernetes. Of course not. That's ridiculous. So you need to find the low-hanging fruit first. And as a maintainer, I want to set you up for success. And I will give you low-hanging fruit and not put you in a situation to get yourself in trouble. You will get the high-trust stuff last if I give it to you, because these days, the source of our software is one of the most important things that we are charged with, maintaining and ensuring that that's healthy. Did I get the timing? Hey, all right. Good first issues. Every project's supposed to have them. A lot of them do not. These are GitHub tags that say, hi, I'm new here. Here's a list of stuff that George says would be a good idea. You click on it. You say, wow, these are awful. I need your help to figure out what you want to work on. Awesome list. Great thing on GitHub, right? If you're a little ecosystem, you're going to be like, I'm going to figure out this thing, and this thing. That's a multiple. It's another part of the ecosystem. Write them all down. Link them together. Tell me that story. You might be the first one reporting that issue, and I have no idea what you have done with my software. So I need your help, and you got to tell me how you broke it. You're probably holding it wrong. Are you? I don't know. Did you read the first few slides I talked about? Different teams, same screens, across all of open source. We got to make sure we're making those interconnecting parts of the ecosystem that they are talking to each other. Because fundamentally, we all have the same problems, and we have to fix them. Please do not argue with me. I am tired. I get 1 hour a day to work on open source. I don't have time to argue about System D today, I swear to God. I paused for effect on that. Yeah. Tell my integration story. What other projects does my project make look good? Like, does it help solve a problem? Connect it all together for me. I don't know. Sometimes I'm so busy, you might find some really, really cool stuff because you were the first one there. Stop complaining about AI and write a human freaking story for me, please. Pause for effect. I suck at YouTubers, man. You all got to do it for me because I have no idea how to. I write Markdown. You have to tell me. Help me connect with YouTubers. Help engage with those audiences so maybe YouTube comments could be actually useful. Well, that's a bridge too far. Help me separate the wheat from the chaff. I am looking for people like Gwen, people who are looking to help fix stuff. That is who I'm looking for. They're going to people that are going to be drive-bys, absolutely amazing. But who I need is I'm looking for the next generation who's going to help maintain this stuff for them. I am sick and tired of you saying I am not an engineer, I'm not useful here. You are all freaking awesome. A lot of therapy going on here tonight. We got to take it seriously. This stuff runs the world. If we don't keep this stuff maintained, we're in deep trouble. Like, this stuff is load-bearing stuff on the internet. I need bodies. I need as many of you to come in and help me. We're going to hang out. And I'm building a project to help teach people how to do it in Cloud Native. It's called Project Bluefin. Build it with me. Build it with us. Thank you. Good night.
Are we all fired up to contribute to open source? Who's going to stay up late, drink beer, and write a blog post tonight? I don't know, too wild? Okay, maybe tomorrow. We'll see how we're feeling. Thank you so much, George. And I'd like to welcome up our next speaker, Kirk, and he's going to talk about his journey towards communicating as a software engineer. Maybe some blog posts, maybe not. We'll find out. Let's welcome him up.
Hey everybody, My name's Kirk, and I'm here to talk my journey towards communication as a software engineer. We all like communication as software engineers, right? I do too. A little backstory about me. I got into tech for my love of communication. Nothing, communicates software engineer like dressing up as a pirate for work. And crap, I got canned recently. Not because I dressed as a pirate for work, though. But getting canned hurts. And, I think I lost a little bit of my career mojo. But then I saw this movie called Sing Sing. And it's about prisoners who use theater to get out of their heads and heal and reconnect. And it inspired me to give this talk. It reminded me of my love of communication and what got me into tech in the first place. And also a lot of the public speaking things I did to continue that. And I'd like to share some of that. I started with meetups. Meetups are great places to talk tech with fellow techies in a very casual and low-key environment. And then I got into some serious stuff, not drugs, hard tech. So I got into lectures on SICP and algorithms. And then I pursued more public speaking things like Toastmasters. If you're not familiar with Toastmasters, it's a place where you can public speak and get feedback. It's no pressure, but it's times like this. Oh crap, I'm not ready. Hackathons was next. They're a great place to practice your Shark Tank pitches. Sometimes you bomb. I bombed once in front of Vince Staples. Then I got into some artsy stuff like theater. I found this meetup online called Eastside Play Readers, and we got to read plays together. This is us reading a play by Larry David. Then I got into something more scary, improv. I love improv because it really gets you out of your head, and it really makes you think. It's not about you, it's about your partner. And last, I did the most terrifying thing for me, which was stand-up. I don't think I got a single laugh during my sets, but I did get a good practice in my humility. Thank you. Okay, you just listed a bunch of public speaking hobbies. What does this have to do with tech or software engineering? Well, I think it's really important to communicate as software engineers. I don't think we emphasize communication enough as software engineers. Meetings are a huge part of our jobs, and if you're communicating well, you're kind of the star player on the team. Software engineers give a lot of presentations to stakeholders, to your team, to managers, and it's just, can't remember this one. Communicating does make the job more fun. It's really great when everybody's in sync and you guys are working together rather than being siloed in front of a screen. And it also helps when you're looking for work. You might be thinking, like, pursuing public speaking is the last thing I want to do when I'm looking for work, but it could be the thing that gets you out of your head the most and gets you moving forward. So I want to encourage everyone to pursue different ways of communication. There's a lot of fun ways to do it, and it can help your tech careers. For me, I plan to do more play readings, more improv, more stand-up, and more importantly, more tech talks, like this one here. Communication can't be done alone, so find me here. I'm passionate about these hobbies. The one thing I learned in improv is callbacks, and if you remember a few slides, I'm looking for a job. So if you have any, please contact me too. Thank you.
All right, so after this, Kirk and George will be doing live improv blog posting. So if you want to participate in that, it's after this. But thank you so much, Kirk. I learned a lot, and I will be saying more yes and this week, maybe, in my improv style. So let's welcome up to the stage Adriana, who's going to do some mindfulness with us. But don't worry, there's Linux too. So let's welcome her up.
Hi, everybody. This is going to be a little tricky. So we're going to do a body thought observation practice, or BTOP. I was a system administrator before I became a yoga and mindfulness teacher, and the two practices have always been intertwined for me, so I'm going to share some of my practice and my perspective. Yourself is a system. It's a computer system. You can monitor it. You can conserve your resources. You can reduce your overload, and that'll reduce your stress and improve your overall health. Burnout is real, right? It's a major issue. Now, we'll do it exactly like we do it with BTOP, right? We can check our temperature, we can check our clock rate, we can find excess processes that we can get rid of, and we can notice when we're dropping network packets with people, right? What did you say? We can poll our system. So while we're doing this, I want you to be curious, not judgmental. There's no wrong way to do it. We're going to observe sensation, all right, however you like. Maybe you think of it in colors. Maybe you think of it in waveforms. Now, a thought will arise. It's supposed to. This is part of the practice. So as thoughts arise, just label them a process. Shove it onto the stack. We're going to push it, and we're going to return to polling, all right? So this is going to be a little difficult with the noise level in the room. You might want to close your eyes, and you can always look at the slide when you need to. So start with your lower legs. Notice where you feel pressure or contact with the floor, and is it different from the right side to the left side? Just notice. Do you feel any air or warmth on your skin? Now as you breathe, as you inhale, maybe tense up your lower muscles, don't get a cramp. And as you exhale, just gently move around your lower legs and feet and relax those muscles, okay? Now you'll notice your attention may be drawn to a thought, maybe a noise elsewhere in the room. Just label it, that's a process. Return to being curious about the sensations in your leg. Now as you breathe, you're going to keep noticing things. We're going to bring our awareness up to the upper leg. Do you feel pressure or contact with a chair? Do you feel any air or warmth on your skin? Maybe your clothing on your skin for the people who are standing? Just notice. As you inhale, maybe tense up the muscles of your upper leg. And with each exhalation, release that tension. You might be breathing at a different pace than I'm going. And just notice any thoughts that maybe arise. Now we're going to bring our awareness up to our lower back and our belly. So activate those muscles in your back, maybe lengthen your spine, draw your belly in. And now your next exhalation, just release all those muscles. Maybe your thoughts come up. Maybe you started engaging with it, and if so, just label it, that's a process. Return to polling. Right now we're still in the lower back and belly. Just be curious about those sensations, okay? Now, chest and shoulders. Let's bring it up to our chest and shoulders, and now bring your shoulders up to your ears, and as you exhale, round them back and relax. Now maybe you have another inhalation and come down. Now expand your curiosity from your chest and shoulders. Start to include your arms and your hands. Maybe tense up your hands and arms. And as you exhale, relax those muscles. Any thoughts come up? Is your attention being drawn somewhere in the room? Process. Set it aside. It'll come back if you need it. Return to noticing the sensations in your body. What's going on? Hands, legs, shoulders. Maybe come up to head and neck. Inhale, reach the top of your head toward the ceiling, and exhale, just gently move your head side to side, maybe turn it. Keep focusing on your breath. Now expand to your whole body. With your next inhalation, head's in a neutral position, and we're just noticing any sensations that come up. If your attention wanders, bring it back. All right, now, if there are thoughts that are overly engaging, if you're wandering off elsewhere in the room, just guide your attention gently back to observing these sensations. Take a deep breath. If you've had your eyes closed, go ahead and open them up. Wiggle your fingers and toes. Bring your curiosity back into the room. Notice lights, sounds, and any subtle movements. Also notice the energy in the room. All right, I will be at the Canonical booth on Saturday. I'll be at Open Source Career Day on Sunday. If you have any questions, please let me know. And that's a newsletter I haven't started yet, but feel free to join it. I have a million of these things. Thank you.
Is everyone feeling more calm, lowered their cortisol? They're ready to raise it up and be really stressed about data? Maybe? All right. We have one last speaker. You guys are doing great at clapping. I'm very proud. Yes. Yes, we're doing great at clapping. We're doing a pretty good job not screaming in the back room because drinks are really exciting. We're going to keep that going for 5 more minutes, just 5. And then the bar is going to be open for a whole nother hour, I promise you. So let's welcome our final speaker to the stage, Dave. And he's going to be talking about the conniption over correlation. So let's welcome him to the stage.
Good evening. Hi, I'm Dave. I work for Nginx. I'm the open source technologist. And I'm going to talk about something ridiculous, data. We all have to deal with data. And I know that I'm standing between you and the bar, so we're going to do that. First of all, if B follows A causes B, right? Well, not necessarily. So we have this thing called data dredging, how to find what we want to find in the data. Given enough data, we can prove anything. And that data can go both ways, by the way. So a couple of terms that may come in here, Pearson's coefficient, which is the number of correlation between data sets for here. The coefficient of determination is basically R squared. And then P, the null hypothesis, would we see this normally? And this is my favorite all-time correlation. Beer and marriage go hand in hand. So does marriage cause drinking, or does drinking cause marriage? So we also have a lot of things to deal with in the internet here. The number of websites on the internet and the total amount of wind power generated globally almost perfectly correlate. It's because of cat videos. Perfectly, totally. And to check this, the same thing fits with solar power. Solar power and the number of websites are almost a perfect correlation all the way across. You can see R is 97 in those pieces. So when you're looking at this, keep in mind all those things. How many people use tabs versus spaces? Okay, if you use spaces, you make more money. Did you know that? That's fantastic. Use spaces. Always use spaces. And oh, by the way, the same thing applies with the space thing if you look at the things in terms of languages. The same rules across over. Spaces earn more money no matter what language you are in. Again, give me enough data, I can prove anything. Chess versus the protein supply in Norway. Okay, the FIFA ratings match up how much meat is served in Norway on a yearly basis. Messi goal scored versus France's labor market. It makes perfect sense. You know, when you watch football, if Messi is scoring for Barcelona, you're probably pretty depressed in France. And oh, by the way, Internet Explorer and murder rates, 100%. Anybody who ever had to support Internet Explorer understands exactly what's going on in here because it's the users that are getting shot. GDP capital versus season wins for the 49ers. 49ers had a bad season last year. I guess Canada did too. So when we look at those various pieces, we can also say, bring back the pirates. We have global warming because we don't have enough bloody pirates. It's perfect sense. We go from all those pirates, as we get less and less, we get warmer and warmer. So let's bring back the pirates. And then if you import lemons from Mexico, your traffic accidents go down. So the question is correlation. Do we have 0 lemons, or do we just import lemons and don't grow lemons here? And then fossil fuel in Germany, marriage rate in California. Again, same thing. So as electronic vehicles take off in Europe, we're going to see marriage decline here in California. Sorry, total fossil fuel is there. And then UFO sightings in Alaska, matching up with paratrain recalls, because everyone knows that UFOs generate a lot of magnetic current, and that causes problems in friction and in heating. Crocodile attacks, and the number of umpires and referees in Massachusetts. At one point, I was a soccer ref. I did work in Massachusetts. I stayed away from crocodiles. It just seems to make perfect sense that you wouldn't have to deal with crocodiles on the soccer field. And by the way, chocolate consumption matches up to the number of Nobel Prizes per country. And if you notice, Switzerland, who does very good chocolate, by the way, is way up there in the top. And then finally, it all correlates. If you dislike licorice, you probably understand HTML. If you can't type without looking at the keyboard, you like thin crust pizza. And if you prefer soft serve ice cream, you actually probably like roller coasters. And then finally, remember, right-handed people cause 90% of all the problems in the world. Thank you.
Clapping, yeah. I do have to issue an official apology on the staff of UpSCaLE that I would have issued a trigger warning if I knew we were going to come after tabs or spaces. So, my bad. Next time I'll warn you. All right, so that actually concludes UpSCaLE for 2025. Thanks for joining us. It's good to see that your hands aren't too tired from all the clapping. You did a job. The bar is still open. I would love for you all to come tell us what you loved about the talks. And if you want, I'm going to give some extra drink tickets to the speakers if you want to tell them what their favorite part of their talk was, because everyone wants to hear how good they did. And drinks are always a great reward. And as a shameless plug, we want to thank Intel so much for paying the bar tab here at UpSCaLE. Sometimes it is free as in beer, and we're here for it. So thank you so much from Intel for being able to facilitate that for us, and thank you so much for all of you for coming.